The raw materials for nearly everything in your life come from a chemical plant in some form. Petroleum products are important globally, and a little more locally, the ethanol industry is extremely important to Nebraska. These and many other industries rely heavily on the separation processes with distillation process with distillation columns being the most common tool to do this, according to lorian.ncl.ac.uk as of March 3rd, 2014. I'm here today to request the funding for a new pump for the continuous distillation column and the UNL Chemical Engineering Unit Operations Lab, which will assist students in hands-on knowledge and understanding of these distillation columns. Today I'll be talking about first why this is important, second what it would entail, and third I'll be giving a cost interview. So first, why it's important. According to Philip Wankat in his book Separation Process Engineering, quote, a typical chemical plant is a chemical reactor surrounded by separators. Raw materials are pre-purified in separation devices and fed to a chemical reactor. Unreacted feed is separated from the reaction products and recycled back to the reactor. So from this, you can tell just how important the separation process is to a site, and this separation process is a job which falls onto chemical engineers. According to Humphrey and Keller, who wrote Separation Process Technology, 40 to 70% of capital and cost come from the separation processes in a plant. And frequently, the majority of those separations are distillation columns because both the heating and cooling costs for them can be extremely high. So because distillation columns are so extremely important to what a chemical engineer will be doing in a field, I'm requesting that the pump for our distillation column in lab be replaced. Replacing this pump would allow for the chemical engineering students to experiment with a greater variety of distillation scenarios, including different chemical structures and compounds, as well as more extreme conditions. So second, I'll be talking about what exactly this would entail. Okay, so what this would entail is right now the pump that is on the distillation column is called a diaphragm pump, and this just means that it kind of works like your lungs in that it expands and it contracts, which also means that the stream that it outputs isn't constant. It comes out in kind of little spurts. So this means that it's very difficult to calibrate as well. From this lack of proper calibration, students can find a lot of discrepancies in their calculations, and it just makes the distillation as a whole a lot more difficult. What I'm suggesting that happen is that the diaphragm pump be replaced by a magnetic drive pump. And so the magnetic drive pump that I have chosen is an extremely chemical resistant pump, which means that you can work with very corrosive materials and still have the pump perform normally. This pump is rated for high volume and high pressure differentials, which just are more extreme circumstances, which are extremely important when doing a distillation. Because this is a magnetic pump and not a mechanical pump, it also means that there will be no heat transfer from the motor to the liquids running through it, which is just important as when you're adding heat, you don't want it to be at the pump. There's more specific locations. Another advantage of having a magnetic motor is that there would be no leaks because there aren't any, there are fewer valves and orifices for it to leak from. But not only would we need a pump, but we would also need a pressure gauge. And this is less for the actual functioning of the column and more as a safety precaution. The pressure gauge would read the pressure, which would help make sure that the pump doesn't go under too extreme of circumstances. Both we're not actually worried as much about the too high pressure as we are about the too low pressure. If you get too low pressure, you would cavitate the pump, which would pretty much destroy the pump and need it to be completely replaced. Um, and so this pressure gauge also acts as a transmitter, so it'll take data and put it directly into the computer system. And so this has two benefits. The first benefit being that it will have the data able for the students to read, and which is great for a live feedback. But the second and ultimately more important one is that because it is being transmitted directly to the computer, is that the computer can override if any sort of dangerous circumstances should arise. So this could be anything from too high or too low of a pressure to liquid or vapor streams not being adequate for safety measures. So these are just the two high cost items that I would ask, and they're both extremely high quality items and would be built to last. Which brings me to my third point, which would be the cost overview. So for the cost overview, admittedly, it is a little expensive, but it'll be well worth the money when it continues to last for years and is high quality products that will allow the students to experience many more scenarios for distillation. So first, the magnetic drive pump would be a cost of $1,077. And this is the main portion I'm asking for. Second is the pressure gauge and transmitter, which is $1,121 and is also very important just for safety regulations. The final addition to the cost is it's just money for various fittings and mounts, just to ensure that all of the pieces and parts get properly attached to the column, again for safety. With these three categories, it comes to a total of $2,698, which I think will be more than worth it once the students will be more than worth it for the knowledge and experience the students will gain. So finally, in conclusion, the chemical engineering students will be gaining so much more knowledge and experience from just this simple part replacement. And not only that, but chemical engineering is one of the fastest growing fields and is extremely important. So having adequately prepared students in the field, especially since many of these students will end up staying here in Nebraska, is extremely important both to the university and to Nebraska as a whole once these students graduate. So today I've told you why it's important to replace this pump, what it would entail, and given you a cost overview, which hopefully has given you the understanding of why this is an adequate use of funding.